My name is Denis Bandurin. I'm an assistant professor at the National University of Singapore, the Department of Material Science and Engineering. I do research in the field of experimental condensed matter physics, in particular low-dimensional quantum materials devices. So in our lab, we explore how such materials interact with mid-infrared and far-infrared radiation. The goal is to explore and understand what are the properties of light-matter interaction in the nanoscale. So I was actually looking for an optical cryostat with a magnetic field, and there were a few options on the market, and OptiCool was great because it has this large numerical aperture. You can ramp magnetic fields super fast in OptiCool, which is not the case in many other systems, so that actually accelerates our experiments a lot. So we are currently actually running an OptiCool 24/7 in our lab. What I noticed from the beginning is that it's super easy for students to get to know the system. So it takes them 1 or 2 days to get familiar with the control units and with how to cool the sample, how to exchange the sample. The main features that we appreciate a lot is the ability to apply a magnetic field 7 Tesla from 1.8 Kelvin to 350 Kelvin all the way with field on. This is something which we do a lot because we do a lot of temperature dependent studies. Also, we leverage a lot of having DC and RF lines in our cryostat because we do high frequency experiments, and we're also thinking of upgrading it to the fiber optics option as well. The best advantage of OptiCool, which we figured out immediately, is the isolation of the sample ground from the compressor, from the pump, and from the control electronics. Being from the transport measurement backgrounds, I was not expecting this feature to be in the optical cryostat system, and all my students appreciated it a lot because with such a clean ground, you can do low noise electronic measurements. So sometimes we even run OptiCool just as a simple, super clean cryostat with low noise capabilities instead of using some other cryostats of other manufacturers. We actually published a couple of papers already. On one of our recent stories, we discovered viscous photoconductivity of hydrodynamic electrons in graphene, which was discovered thanks to OptiCool. So I think it's a perfect system for someone who wants to do optoelectronic measurements in the presence of magnetic field and at cryogenic temperatures. In Singapore, we have a representatives of quantum design. So we have an office there, and Leo team leads it. So whenever we need help, we just text him and he would respond immediately. So actually, we've never seen such a service before. We also really like aesthetically how the OptiCool works. I think its design is pretty cool. I think someone put a great effort into designing this machine.